So this is going to be our review for Exam 1, Part 2. And we're going to do in the practice exam problems 23, 26, 29, 30, and 33. So 23 is a rate problem. So I kind of wrote down the problem. I summarized it more or less. Lots of times they add a lot of words that require you to find the most important part. So basically it says Andrew can paint a house 5 times as fast as Bailey. When they work together, they can paint a house in 2 days. How long would it take them to paint one house? So this is a rate problem. And remember, rate is a ratio, which means basically a fraction. But the number in the top part usually has a unit that is different from the bottom. You know already about rates. Miles per hour. Miles over, that's distance over time. When the top part, distance is different from time. Here we more or less have the rate of painting is the number of jobs, meaning the number of houses they can paint in time, which I've just said is J over T. But in particular, the jobs is the houses, the number of houses, and the time is in days. So what we normally do when we have a problem, when we're comparing two rates, is we draw a little table. I shorten Andrew to Drew and Bailey, and then we put the major components of our guiding formula here. So I'm going to put this as job, and then time, and then rate. So we want to have a guiding equation, because we're going to fill this out, but once we fill it out, we have to have a guiding equation. So basically, the equation is Drew's, just in kind of shorthand, Drew's rate, and by that I mean his rate of painting a single house, plus Bailey's, well, what does that equal? It's equal to the rate of both. So we're talking about if you add a rate to another rate, you get another rate. That's important. So we're going to use this equation to help us out. So let's read through here, go back, and we will decide what our x is, and we'll decide that by reading through it. So Andrew, or Drew, can paint a house 5 times as fast as Bailey. So if I let x equal Bailey's rate, or Bailey's, not rate, but, sorry, times as fast, it's Bailey's time, then I'm going to put an X right there for Bailey's time. And it says Andrew can paint a house 5 times as fast. So the time that Bailey can paint the same house is 5x. And what is the job? A single house, a house. So their jobs are one house. So now I need to fill out the R column, but R from this equation up here is equal to J divided by T. So that means 1 over 5x. That's Drew's rate. And this is 1 over x. And that's Bailey's rate. So let's go over here and let's fill in what we can of our guiding equation. Drew's rate is 1 over 5x. And Bailey's rate is 1 over x. And we have to find out from the problem What is the rate of them both? Well, they can paint a house in 2 days. So their combined rate is one house, and remember the denominator is day, is 1 over 2. So literally now I have an equation. So let's solve this equation. So my equation is 1 over 5x plus 1 over x is equal to 1/2. So I want to clear the denominator, so I need to find the LCD of 2x and 5x. So what we do is we can make a table, prime factors, and of those, well, I thought I had it selected. We have a 2, an x, and a 5. So when you're looking at the prime factors, you look at the variable term and the constant term. 2 is prime, and 5 is prime, and I only have one variable term, that's x. Now what we want to do is just list all of the denominators. So my first, this is called my table method for finding the LCD. So my first denominator is 5x. My second denominator is x, and my third denominator is 2. So now I go. You can go either way. Let's do it differently. Let's look at 5x and see which of these factors occur in 5x. 2 does not occur in 5x. 5 occurs once, x occurs once. Look at my x term. Does 2 occur in my x? No. Does 5 occur in my x? No. X occurs as one factor in itself. Does 2 occur in 2? Yes, once, one factor. 5, no. X, no. So as you recall, now my LCD of these terms is equal to my prime factors, 2 times 5 times x, but each one of these prime factors is raised to a power. And for the LCD, we glean the power by looking at the largest number in each of the accompanying rows, and that's just 1. So 2 to the first times 5 to the first is 10. It's just the same as 2 times 5. X to the first power is x. So my LCD is 10x. So again, be really careful. We want to enclose both sides in parentheses, and we want to multiply both sides by the LCD, which is 10x. Now, the result of doing this is we're going to have an equation without fractions. So when you're doing the test and you feel pretty confident that you found the LCD, and you get to this step right here, once you use distribution to simplify the left-hand side, and just regular multiplication to simplify the left, the result is going to be something without fractions. If you have fractions, then one of two things have happened. You've either gotten the wrong LCD, or your multiplication step distribution of the 10x term here over the 1 over 5x plus 1 over x somehow went wrong, or your 10x over here divided by 1/2 went wrong. So let's do this carefully. 10x times 1 over 5x is the same as 10x divided by 5x. The x's cancel, so that's 2. 2 times what? 2 times the numerator. 10x times 1 over x is the same as 10x divided by x times 1. The x's cancel, so that's plus 10 times 1. I'm writing the denominator in there just so you can see it's still, the numerator in there, just so you can see it's still there. Now if you want to just go, oh well, the x's cancel 10 divided by 5 is 2. 2 times 1 is 2. 10x, x, the x's cancel, so this is just 10 times 1, that's fine. And over here I have 10x divided by 2, and that's equal to 5x. So that gives me the equation 2 plus 10 is equal to 5x, or 12 is equal to 5x. So now I can solve for x. I divide through by 5, and 12 fifths is equal to x. And what is x equal to? It's the time it would take Bailey to paint one house. So how long would it take Drew to paint one house? Well, Drew's time is 5 times x. And 5 times x is equal to 5 times 12 divided by 5, which is equal to 12. So it would take Bailey 12 days, and it would take, because the time is in days, and it would take, no, this is Drew, sorry. This is Drew. This is 12 days. Because it takes him 5 times longer. And Bailey takes 12 fifths day. If you want to know what that is, that's 2 and 2 fifths day. So it takes Bailey about 2 and a little bit, almost 2.5 days. And it would take Drew 12 days. So of the two, you would know which one you want to hire, right? So let's move on to another problem. So this is going to be problem 26. These look much more difficult than they turn out to be. So I have, let me write this down just a little bit. I have 2x minus 6. And that's going to be a base raised to a fractional power. And that's going to be equal to x to the 1/3. So we're going to note that the numerator is equal to 2. And 2 is even. So that's going to flag us, that's my flag there, that we may need to take a plus or minus somewhere in there. In this case, it'll turn out that we don't. So what's the procedure? We look at the right-hand side is what we'll do this time, the left-hand side rather, this side right here, and its exponent is 2/3. So the reciprocal of 2/3 is 3/2. So that's what we're going to do, is we want to raise both sides to the same power, but we want to choose the power wisely so that it makes one of these terms raised to the power of 1. So that's what I'm going to do. I've chosen to do that to this side. There you go, selector. And so what I'm going to do is I'm going to raise both sides to the 3/2 power. Now notice that the 2 is in the denominator. And recall, x to the 1/2 is the same as the square root of x. Remember, sometimes when we use the square root property, we have to take plus or minus. So we're going to do the same thing over here. We're going to raise this to the 3/2 power. So the 2x minus 6 to the 2/3 power to the 3/3 power is 2x minus 6 raised to, I multiply these two powers, 2/3 times 3/2. And over here, I'm going to do the same. I'm probably in not the best color. This is x to the 1/3 times 3/2. So let's go ahead and simplify in terms of powers. This is going to be 2x minus 6. 3/2 times 2/3 is equal to 1. So I literally got rid of this power. This is just 2x minus 6 to the first power, which is 2x minus 6 outside of parentheses. You can keep the parentheses in there, but there's no need to, and it may mislead you to think that somehow they're corralled in there and you can't move the 6 to the other side or something. But what happens over here? I need to say this is plus or minus x. 1/3 to the 3/2 is x to the 1/2. But as it turns out, we're going to be okay. So that's, if you want to, over here. That means the square root of x plus or minus is equal to 2x minus 6. But as it turns out, we don't have to worry about the plus or minus, because I have to get rid of all my radicals. So what I'm going to do is I'm going to take this entire side, and this is kind of an abusive notation, and I'm going to raise both sides to the second power. In doing so, just remember that minus b, for any real number b, minus b squared is the same as b squared. So this plus or minus here doesn't matter. It's just going to go away. So x to the 1/2 to the second power is just x. And this over here is, let me get some space. This is just 2x minus 6 squared. I'm going to use the formula. That's 2x squared, which is 4x squared. So when I say 2x squared, I mean 2x in parentheses squared. So that's 2 squared times x squared. Minus 2x times minus 6 times 2. So 2x times minus 6 is minus 12x times 2 is minus 24x. And then the final term is minus 6 squared, so minus 6 times minus 6 is plus 36. Oh, so I literally have a quadratic equation now. So I want to go ahead and rewrite this in the form ax squared plus bx plus c is equal to 0. So that means I need to subtract x from both sides first. So minus 24x minus x is a minus 25x plus 36 is equal to 0. So now you have to solve for x when you have a quadratic equation. And here I will tell you, you all get to decide. And I'm way more sympathetic to this than some of my colleagues. You're in a test, the clock is ticking. You do not know if this can be factored. This trinomial here may be prime. If it's prime, you have to use the quadratic equation. However, if it could be factored, it's probably easier to factor it. It'll probably get you an easier result, because when you use the quadratic equation here, you're going to be dealing with some large numbers. So on the exam, if you use the quadratic equation, if you decide to go the quadratic equation, no problem from me. But you have to show your work. You literally have to show your entries in x is equal to minus b plus or minus the square root of b squared minus 4ac over 2a. Show at least one simplification and another simplification before you get it. So this would require minimum 3 steps if you go that route. And if you go that route, I don't really care if you use a calculator. But we're not going to go that route. We're actually going to factor it. So how are we going to factor it? I factored this earlier, and I like to do this because part of this question is, well, we review past practices. And again, I'm factoring things differently than some of you may. This is really just this is equivalent to the guess and check method, but it seems to work better. So I put my first term there, then I skip down and I grab my constant term. This just looks to me like it's something that it could be factored. And then I put my middle term here. Now here, unfortunately, since my leading coefficient is 4, I have to do some guessing. I could put 2x times 2x, and that gives me 4x squared, or I can just put x times 4x. I've already done this before, so I'm just going to write down the answer. So x times x, when I multiply across, gives me 4x squared. Now with 36, we've got to do some thinking here. 36 is 6 times 6, 9 times 4, minus 6 times minus 6, minus 9 times minus 4, and there's some others too, 12 times 3. So whatever I do, whatever I put in those two cells here and here, I have to multiply down, and I'm going to add them up, and it's got to be a negative. So the only way I can add two numbers up than which they're a negative, but the product is a positive, is to choose the following. Choose the negative value of both. Minus 9 times minus 4 is plus 36. So x times minus 9x is minus 9x, and 4x times minus 4 is minus 16x. How nice, because now is the addition step. Minus 9x minus 16x is minus 25x. So my box is filled with the correct values, but to take the factorization, I have to do this kitty corner thing. And that gives me my factorization. My factorization is x minus 4 times 4x minus 9 is equal to 0. Now I'm so happy that I did this, because this is so much easier to solve. This means either x minus 4 is equal to 0, or 4x minus 9 is equal to 0. And literally, you should at this point by now, you should be able to solve both of these really in your head. This implies x is equal to 4, and this implies x is equal to 9/4. So our solution set contains two values, 4 and 9/4. So this is a clue here. Since this was taken from a problem that is generated by MyMathLab, and they try to make all the problems similar, and I was able to factor this polynomial, then no matter what numbers you're given, the polynomial will be able to be factored. So if you see this on the exam, remember, well, it would be worth trying really fast to see if you can get a factorization. If you're really shaky with your factorization, use the quadratic equation. You know, math allows you to make some choices, and some of those choices, and whenever you're given choices in math, if the choice is valid, they'll both lead to the correct answer. So the choice is subjective in how you want to make it, and you get to make that choice. It leads to a valid question. A valid answer. If you use the quadratic equation, there's a lot of things you're going to have to do. In particular, you're going to have to take the square root of a really large number. Now that really large number is going to be a perfect square, but it's not going to be one that you literally can look at and say, oh, that's a perfect square, unless you've got a really good memory and you've remembered a lot of perfect squares. So you literally have to use the square root key on your calculator, which isn't cheating, but you know, this way I didn't have to. And your retort is, yeah, but this was created special so that it would work out that way. And that's when I pause and say, you're exactly right, it was created special, but it's still a good skill to know. So let's go on. We're now on problem number 29. So this is an inequality. So we have 14 is greater than 2x plus 6, which is greater than minus 2. And this is kind of out of order, right? You're used to seeing equations where some number a is given here, it's less than some algebraic expression p. So p stands for a polynomial, for example, which is less than some number b. And if we look at our number line, that's kind of the natural way to look at things, because the ordering of the number line is this way. If a is here and b is here, then a, and p is here, then a is less than p, and p is less than b. So what I'm going to suggest is we employ a trick. Remember, if we multiply all three parts of a inequality by the same number, then it's still an equality. An inequality. It preserves the inequalityness of it. However, if that number is less than 0, we have to flip the signs. So I want those signs flipped. I just want them flipped. So I'm going to multiply this part, and this part by minus 1. I want the numbers to stay the way they are. I can multiply them by minus 2, minus 3, minus 1,000. But minus 1 keeps the values small, but it does what I want. It flips the equation. It flips the inequality sign. And here's what I'm going to tell you to do. I just graded, spent 2 very long days grading intermediate algebra papers. This was the major mistake they did at this point when they had something similar. They did not multiply every term in the middle by minus 1. They just multiplied the 2x. So I'm going to suggest that when you do this, if you're not really good, that you put that in parentheses. So now let's multiply everything by minus 1. So minus 1 times 14 is minus 14. That flips this sign. Minus 1 times 2x plus 6 is minus 2x minus 6. Flip the inequality. And minus 1 times 2 is 2. So that's nice. I'm done. I have, I'm going to use this space down here, so I'm going to erase this really fast. So now I have the direction of the inequality the way I want it. Now you might be asking, do you have to do that? And the answer is no. If you want to leave them facing this way, you're fine. But the end thing is we have to write the answer as an interval, and the interval uses this notation. For some numbers a and b, a is less than b. So I like to do it this way. The point is that this original inequality that we were given has the exact same solution set of this transformed inequality. So again, what we want to do is we want to probably not going to help in the end. I just saw a complication. Well, it's fine. We're probably going to have to flip this, probably going to have to do one more flip, because I turned the coefficient on the 2, the coefficient on the x term, to a negative. So we will have to do one more flip in the end. So the point here is I wasn't thinking far enough ahead. I'm going to have to undo the direction of the inequality one more time, but that's okay. The point that I can still make here is that this inequality has the exact same solution set as this one. So again, let's just go ahead. Let's add 6 to both sides, to all three sides. So I'm going to add 6. So 14 minus 14 plus 6 is minus 8. Minus 2x minus 6 plus 6 is minus 2x. And 2 plus 6 is 8. Now here is the unfortunate amount. I should have actually, usually it's better to get them this way, but because of what I said over here, but we're going to have to redo something. I've got to I want to find out what x is. We need x right here. So I have to divide all three parts by minus 2. And by doing so, that means I have to flip the signs back. So minus 8 divided by minus 2 is 4. Flip the sign. Minus 2x divided by minus 2 is x. And 8 divided by minus 2 is minus 4. So now I can rewrite this without changing or multiplying through by a negative. This says x is greater than minus 4. That's what that says right there. X is greater than minus 4. This says x is less than 4. That says x is less than 4. So the interval now is minus 4 to 4. So notice, this is the part I'm worried about right here, is when you write the interval notation, you'll write 4 and minus 4. So at some point, you need to change these. It's a good idea. You don't have to. You need to change the inequality signs to this direction. So we could have done actually, let's do this. If you're bored and you got it, you can go on. Let's go ahead and do this one different method. And our original was 14 is less than minus 2x plus 6 is greater than minus 2. Since you see, did I write it down wrong? Ah, that's the reason. Okay. So the original, sorry people, the original actually has, in my generated file, has 14 is greater than minus 2x plus 6. And that's again one of the reasons I flipped the sign. So let's look at what I originally had. There's another way you could have done this. Well, there we go. Sorry, you can fast forward if you're just curious. So here's my original. 14 is greater than 2x plus 6 is greater than minus 2. So for this one, which is, I copied the problem down to the screen different than what was on my paper. The way you would want to do this would be just rewrite this side. 2x plus 6 is greater than minus 2. So that's the same as saying minus 2 is less than 2x plus 6. And saying 14 is greater than 2x plus 6 is the same as 2x plus 6 is less than 14. And now you're done. Now you just go through and you would just subtract 6 from both sides. So this is minus 8 is less than 2x is less than 8. And then you divide through by 2, and you get minus 4 is less than x is less than 4. So your interval is minus 4 and 4. That's where your x lives. That's your solution. So part of the problems there was the original problem was not what I wrote down. And this step right here is flipping the signs. It was indeed a good idea in the problem I have written down on my paper, because the problem I have written down on the paper has 2x with a negative sign. So that's what was going on there. So now let's do problem 30. So here I have an absolute value, and it's 9 over x minus 5, and it's equal to 11. This is really no problem to solve. This is really no problem because we have, if p is some polynomial or some algebraic expression, and the absolute value of p is equal to some constant r, then that means p is equal to r, or, remember that, p is equal to minus r. And that's all we're going to do here. Literally, there is no problem. So here I'm going to take the 9 over x minus 5, and the original problem doesn't have x, thank goodness. And the original problem has 11. That makes it much better. So 9 over x minus 5 is equal to 11, or 9 over x minus 5 is equal to minus 11. So here what we want to do is we want to multiply both sides by the denominator. When I do it on the left-hand side, it clears out the denominator. And over here I get 11 times x minus 5. Let's go ahead and solve this side over here. This tells me 9 is equal to 11x minus 55. So 9 plus 55 is equal to 11x. 9 plus 55 is 64, is equal to 11x. So then we're going to divide both sides through by 11. Remember, this is an equality. This is, I guess, one thing to think about here is this is not an inequality, this is an equality. This is an equation. There's a difference. So the final step here is that 64 divided by 11 is equal to x. But we have to do this side over here. So again, we're going to multiply both sides by x minus 5. So that's equal to 9 is equal to minus 11 times x minus 5. So that's 9 is equal to minus 11x plus 55. So now I subtract 55 from both sides, and I get minus 46 is equal to minus 11x. Now I divide both sides by minus 11. So 46 by minus 46 divided by minus 11 is just 46 divided by 11, and that's equal to x. So my solution set is x has two values, not an interval, just two numbers. And that is it. Just two numbers. And one last problem, and we're done with Part B review. This is problem 33. We have 4 times the absolute value of x minus 4 is greater than 16. So we know we have, if you look at the table, that if some expression p in absolute value is greater than k, that means p is less than minus k, or k is less than p. So that's the number line. You'll have to go back. So I want to get it in this form. P in this case is an algebraic expression. In this case, it's a polynomial, x minus 4. So 4 times some positive number is greater than 6. What I'm going to do is I'm going to divide both sides by 4. I'm going to simplify it. So that gives me the absolute value of x minus 4 is greater than 4. So now my p is equal to x minus 4. So p in this case is x minus 4, and my k is equal to 4. So that means x minus 4 is less than minus 4, or 4 is less than x minus 4. So let's solve this one. So I'm going to add 4 to both sides. This tells me x is less than 0. Or over here, I'm going to add 4 to both sides. 8 is less than x. So what you have to do is you're going to have to take the union of two intervals. So let's write both of these in interval notation. The values of x less than 0, well, that includes minus infinity up to 0 but not including. We're taking the union, and here x is greater than 8. And if you look at our two number lines, there is no simplification of that union. So two number lines, in two ticks. One of those is going to represent 0, and the other is going to represent 8. And for the top value, for the bottom value, we take all numbers less than 0. And for this interval, we take all numbers greater than, but not including 8. So you want to put that here and that here. So when I take the union of them, there is no simplification, because there's this middle part right here where no numbers in either of the two number lines are included. So that is our solution, and that is written as simple as it can get. So that's it for our review. That's number 33. And if you have questions about any of this, feel free to email me.